Welcome to the Southwest Climate Podcast, the Grumpy Edition. I even had a hard time actually saying welcome. Mike?
Zach?
You and I are going to break down this monsoon, this historically dry monsoon season, for many of the wrong reasons. But before, Mike, I know you've been suffering and this podcast is some therapy for you. So what's your rant? Give me your best rant about this monsoon season.
You teed me up for this. I ranted to you and Ben on Slack last week, and I just spent myself. I think I went right to bed after I ranted on Slack, and I slept for a couple of days. I'm at this weird kind of acceptance that I live in Gila Bend rather than Tucson.
Just for the record, for everybody listening, there was like a week period last week, I think, where it was like apocalyptic, the stuff that was coming out of your mouth. Like, I'm giving up. Like, I'm not waking up until 2021. I can't wait for the monsoon season to be over. I'm done with it. Like, those were all coming out of your mouth. You're
right. I had so much resistance to the moment that I created all this suffering. And then I'm kind of zen now. I don't even expect it to rain for the next 10 days. I don't care. Don't care.
That's depressing.
It's a little depressing, but it's like kind of my coping mechanism right now. It is August 7th. It should be miserably sticky outside, and we should at least even be socked in by clouds. And dew points are in the low 40s. It's like May 31st forever.
So I was thinking about this on the way over here. I was trying to come up with a couple names. So I got a few bad ones.
Okay.
Maybe a good one.
Yeah.
So tell me what you think. I got the fake soon.
Ooh, that's good. That's really good.
What about this? The June soon.
It's a thinker. I like it. Yeah, got to think about it.
So then I was thinking, going a literary route. What about Dante's Monsoon?
Oh, nice. Yeah, which level? Are we kind of the outer ring?
The first one. This
okay.
Is like
You're not even going to go to the deeper levels of the Inferno? You're just going to stay in the outer skirts? Yeah. Or are you reserving that we could go deeper into...
We can go deeper.
Okay, I like this. I like this. This levels idea.
And then because I've got an infant, and so I've got like infant brain.
Yeah.
And quite frankly, a lot of our Slack conversations devolve into this kind of humor anyway. But what about the crap soon?
We had some more colorful, but I think we're trying to keep this a all audiences podcast.
I like the June soon.
I like June soon too. That's really good.
Okay, so we have to explain what's gone on so far. First half of the monsoon, we're close to, if Mike, you can correct me if I'm wrong here, but we're just a couple days off from the climatological midpoint of the monsoon.
Yeah, I think we've crossed the threshold. We're on the downhill part of the roller coaster.
It's been a very bleak monsoon across the state. I mean, not only across the state, across the region. There's a few stations, and you have to go to New Mexico, that light up where they've done slightly better than average, but those might even be errors. I'm not even sure I'm convinced that that's true. I mean, it is a bloodbath across basically all of Arizona. Looking at just the June through July, so just discounting the last 8 days. So we're coming out to you at the end of the first week in August. And basically for all but the northeastern corner, we've been in the bottom 10 percentile of precipitation. That's according to the Westwide Drought Mapper.
For July, it was the 6th driest July on record for Arizona in the statewide rankings.
And then relate that to it's been the 10th warmest as well. In the summer here, there's obviously correlations between rainfall and temperature. So when you get low rainfall, you also get hit with high temperatures just because the cloud cover is not there and you don't get the evaporative cooling. So it's not surprising that the two go hand in hand. So yeah, it's been unfortunately very warm and unfortunately very dry. But if we look Arizona as a whole, 6th driest, let's just go around to some of the cities. Boy, Phoenix has had, at the airport itself, has had a 1/10 of an inch.
One event.
And so normally, it doesn't get a lot of rain, but normally at this point, we're talking something like a little bit over an inch.
Not even a dust storm. I mean, come on.
Okay, so Tucson, 0.66, and this is data through yesterday. And normally at this time of year, we'd have close to 3 inches. Ooh, brutal. Flagstaff has fared slightly better, 1.5 inches. And at this time, it's gotten more rain, but it's still running at about 50% average. So one would expect at this time of year around 3 inches. So moving along to Albuquerque, New Mexico has done slightly better than Arizona as a whole. New Mexico's received about 1.5 inches of rain. And at this time of year, they're close to 2 inches on average.
For where?
Albuquerque.
Albuquerque. Okay, thank you.
What did I might have said that wrong, but it is Albuquerque.
I wasn't paying attention.
And then El Paso. So these are the 5 cities that we've been doing our game with. El Paso is about 1.5 inches as well. And at this time of year, close to a little bit over 2 inches. So 75% of average for both El Paso and Albuquerque or thereabouts, and much less for those cities in Tucson. But if you hone in to just the Southwest, which is, just the Southeast Arizona, the footprint of the monsoon here in the Southwest, it's equally bleak. So Nogales Airport running at about 50%, Safford Airport, 0.4 of 2.7 inches. So, 25% or something along those lines, maybe even less. Sierra Vista, 2.5 inches, whereas it normally gets at this time of year, 4.4 inches, and so on and so forth. So we could go around, Mike, but it is a very dry picture across the Southwest. Not what we wanted. How the heck did we get here?
I want to put a little finer point on this too, because, and this is weird coming from the place that I was last week and the really dark thoughts I had, but we were kind of talking earlier that it actually has rained. It has rained in some locations. And I think, as the monsoon often does to us, there are pockets across the Southwest that actually have had an event or two that puts them close to seasonal totals based on heavy precipitation. And so, I think the ranking for New Mexico, statewide July ranking for New Mexico was 48th driest, which is not even in the bottom third of that, right? And I'm not trying to paint that it's all hunky-dory over New Mexico, but they have had more precipitation as far as the number of events and the extent of the events, but there are certainly pockets. And the closer you get to Arizona, the worse it gets. So we really have this gradient across the Southwest from east in New Mexico to far western Arizona, which has had, along the Colorado River Valley, which is not monsoon central, they have not seen an event yet that has actually reached to western Arizona.
It's not uncommon for those events to race from the east to the west. So they hit Tucson and screen through Phoenix. I forgot what they're called. You had a name for them last.
Oh, there's kind of the rim shot, kind of the Weather Service will call the development of storms that occur along the Mogollon Rim and are in really good, strong easterly flow will propagate into the low deserts. And I don't think we've had a single event that has had that setup yet, which requires the subtropical ridge to be in the right position. And the Four Corners High, as part of that mid-level subtropical ridge, puts us in that deep easterly flow. And we just haven't had it. I mean,
it is worth pointing out that the monsoon season brings quite a bit of variability. We've talked about this. So you can get these convective storms that happen in pretty isolated fashion. And we've seen that even in Arizona. New Mexico has experienced, on average, more rainfall, more events than Arizona. But what's been the synoptic setup, Mike, the regional picture here that has led to more moisture in New Mexico and just frequently dry picture in Arizona?
It's been what we were worried about at the beginning of the season. It's similar to what happened last summer. We ended up having a mid-level trough of low pressure off the California coast kind of encroach upon the Southwest and put us into westerly flow. And, the postmortem after the 2019 monsoon was that there may have been this kind of weak El Nino forcing that kind of lingered in the atmosphere. And there was a wave pattern across the mid-latitude jet stream that led to that. and us shifting into neutral conditions and into kind of weak La Nina. I don't know if we're in weak La Nina officially yet, but we're under La Nina watch conditions, was going to yield way to a different kind of mid-latitude pattern. And it hasn't. We've had a really, and I think it's for different reasons this year, and it's not totally clear to me, but there's been a really busy mid-latitude kind of jet stream pattern and a strong mid-level ridge of high pressure in the Pacific that's led to this deep trough off of the California coast that has nudged its way into Arizona. And if you get that trough nudging in here, it's going to force the subtropical ridge off to the east, and it's going to shunt any southerly flow in the mid-levels off to the east. And we instead get into the kind of the May dry air flowing into Arizona.
So is that why there's been, maybe the setup has been a little bit more favorable for incursions into New Mexico, but it's basically at the border sort of been blocked, if you will?
You look at the daily weather maps and it's kind of this mess of transitions here and there, and a pattern will open up and it will favor a good southerly flow out of Mexico, and it kind of goes off to the east. And so I think in the last couple of weeks, especially, you've seen like far eastern Arizona and southwest New Mexico kind of pick up on this action, and it flows north. Far eastern New Mexico has been caught up in some dry air as well, just given the overall flow pattern we've had. And we really haven't opened up the Gulf of California all that deeply because we don't end up having the subtropical ridge in the right spot, and we haven't, flared off a really good organized storms through Mexico as well that would trigger some of these Gulf surges. So it's just been this real kind of, just a weak monsoon pattern. It happens. We see it in the record. Mexico itself is below average. So it's been below average. If you can go all the way down to, like 10 degrees north latitude and see below average precipitation anomalies. But the bulk of the below average precip is really in the far northern periphery of the monsoon system. And even in the last couple of weeks, northern Mexico has picked up a lot of activity and is caught up a bit and is near average, still slightly below average for the last 30 days.
There just has been in Tucson, now honing in on Tucson, there's just been little moisture so far this year. And I looked at the dew point data, and it's turned out that if you average the dew point temperature from the beginning of the monsoon, so July 1st through August 8th, it's the fifth lowest dew point temperature average since 1973 when the data that I looked at. So, and that dew point's just a measure of how much humidity or how much precipitable water is in the atmosphere. So one of the core ingredients has just not been there. I mean, I just looking at the dew point plots from the National Weather Service, I mean, there are very few days where they're at. I think there's been 4 or 5 days where they've been actually above the climatological average. So just really bleak in that sense too. So historical in the sense of just really low moisture availability. And then when there has been moisture available, Mike, I remember, what was it? Was it last weekend? I think it was last weekend, first couple days in August, where we had quite a bit of dew point temperatures were high, and yet we were still under sort of upper level westerly flow, and the entrained smoke from the apple fire in Southern California, which suppressed the temperatures and really reduced the ability for the Cape or the ability for the atmosphere to sort of be buoyant. It was like just insult to injury.
That was the darkest day of the summer for me. I had palpable anger. I was in a bad mood because I remember waking up and the sky had that red kind of tint to it, and I thought, what is going on? And it took me 6 hours to actually realize it was smoke. And I remember slacking you guys going, is there something on fire around here? And then I finally got on Twitter and realized it was LA was on fire. Of course, that makes perfect sense. That LA would be on fire and there'd be smoke from California making it into southern Arizona in the middle of the monsoon season in August. That is not normal. That was very frustrating on that particular day.
Yeah, no, and it took a couple days away where we had really high, like the atmosphere would have been primed, Well,
it was really, it was interesting because it was like the third day of CAPE. We talk a lot about CAPE, convective available potential energy, which is that going to be a metric that we can look at that's going to give us a sense of what it says is the potential energy for thunderstorm development, was really high for a couple of days. And it was because we were on the edge of this trough, which lowers the upper level temperatures. But we also had a bunch of moisture, a really weak surge sneak in underneath that. And so that's like an event you'd see at like the end of September with those kind of two things. And then the CAPE gets really high, and it's what really can be really explosive thunderstorm development. And the smoke took a couple of degrees off of the afternoon temperature, which then just took the edge off of any potential development. And some storms formed off to the east, and we're actually, I think, some of the better thunderstorms. The storm chasers were out checking them out, and we just watched on the sidelines. And it's just, the monsoon is a spectator sport. It really is. If you live in Arizona, it's a spectator sport.
You root for it like sports as well. I mean,
oh, you totally do. But
when your team loses, you can't get out of bed.
No, it's exactly it. Yeah, it's like this year was so totally possible, just in the realm of natural variability. It was a low probability event, but I think we were kind of talking too, it's not unheard of, and it's not an outlier in any sense of the word as far as any of the metrics we're looking at. It's just a bummer. It's what it turns out to be so far.
Well, I think we're in position now for it to be an outlier. I mean, it could, we could find ourselves, if nothing happens going forward and we don't get, a tropical storm that wafts in here in September. I mean, it's now much more likely that we're close to record dry than we are on the other side.
I give you that. And I think that, like this week that we're, it's August 7th, and we're kind of going into the second week of August. Like this beginning 2 weeks of August is prime time. Like climatologically, it's like the dew points peak, the probability of precipitation peaks, the different types of organized events usually peaks because the moisture is typically available. Well, this year it's not even close. Like we don't probably have any surprises in the forecast even for the next 7 days for any of Arizona. Like it's total. New Mexico is still kind of in this pattern where they're going to get some moisture pulled up from the south and, spark some storms. But Arizona's forecast for the next 7 days looks completely dry. And so you're right. So like at the end of next week, we start to get into, okay, this is much rarer. And we have to give due the fact that the temperatures are they're definitely correlated with precipitation, but the trend and the climate change signal on top of them takes dry bummer monsoons and makes them
miserable.
Makes them miserable and much more dangerous. Yeah.
Yeah, I want to add to that. So Phoenix has had 1 day of rain thus far.
Yeah.
And it averages 12 to 13 days a year, or a monsoon season. So, if we're halfway through, Phoenix has missed out on 5 days for the most part. Like we're not making that up. Tucson has had 4 rain days, and it usually gets 25. So we should be at like 12, 13. So we've missed out on, 8. We're not, I would bet all my money, not all my money, but a large fraction of what little money that I have on that, when we look back on this, we're not going to be above average in Tucson, in Phoenix, in Flagstaff. I won't say anything about the New Mexico major cities, but I mean, would you take that bet, Mike?
Yeah, I'd take that bet. I mean, and you just go back and, our records with the daily precip only go back to the early 50s, late 40s, so we've got 60, 70 years to look at. So we don't have 1,000. That would be really handy to see, but you don't see many situations where you end up having frequent rainfall events past this event through the end of the monsoon season. I can see 2 ways of getting to average now, which would be, the 2 possible ways would be a whole bunch of evenly spaced out small events that add up, which you'd have to do that in a crunch time. So that's super unlikely. or a handful of like really big kind of catastrophic events. And so Tucson is to get to the 6 inches, we would need, what do we have? Like a half inch right now?
Like a little bit, a little under 5.5.
Okay. Yeah. So we need 5.5 inches. So what are the chances of us getting 3 1.5 inch events at the airport? And this is the other thing too. This is the stupid part of the game, is that they'd have to hit the airport. We've already had one event in Tucson where numerous rain loggers and flood control network gauges and CoCoRaHS observers observed over 3 inches.
Right. So let's talk about this, because I think this speaks to your point a little bit earlier, which is there has been areas where it rained quite a bit. And, in our cities, we have quite a bit of people who are measuring it in their backyards. And so we have much denser networks. But, as you go in the rural areas, we obviously don't have the spatial coverage. So we don't actually know where it did rain or it didn't rain. But on July 23rd, so I'm talking Tucson here, in the Catalina foothills area, there's like 4 or 5 rain loggers who, as you say, recorded rainfall, about close to 3 inches or above. And then another set, let's say south of the Tucson Mountains, slightly south of the Tucson Mountains, that also had, some of them actually, one of them recorded 4 inches, but 3 of them recorded a little bit above 3 inches. So, but the rest of Tucson itself, there was rain for sure, and many more rain loggers noted rain events than didn't, but not nearly of the magnitude.
I pulled up some of the cooperative observer data from around kind of the whole state, but I was really drawn to a couple of observations down here just near Tucson. So where Cascabel is, just over Reddington Pass, and it's down in the San Pedro there. There's a cooperative observer there who has, since June 15th, recorded 4.78 inches and only 6 missing days. And that's 1.9 inches above average to date. The observation looks good. The peak event, the biggest event that station occurred was on July 11th. And they recorded 1 3/4 inches on that date. And I went back and I looked at the maps to just make sure that wasn't erroneous. And there was a tiny little thunderstorm that occurred on the other side of the mountain range here outside of Tucson that dumped that precip event. And then if you go down south of Tucson, Green Valley, it's probably the same distance. If you go to Cascabel to the east, but you go south to Green Valley. So there's a station that's recorded 0.96 inches since June 15th to present, and they're 3.15 inches below average. That's the craziness of the monsoon, is that just in like our little microcosm of just the Tucson area, we have 2 season areas that have above average and below average, but not even close to each other. Like the deficits are inches apart from each other. I think that during dry monsoon seasons, this becomes even more stark, because there really aren't seasons where it just doesn't show up at all. I think the dry seasons look like this, which is where, from June 15th to present in a dry season, there are locations that have gotten hammered by convection and thunderstorms, but it hasn't been very frequent and it hasn't been very widespread.
In any season, there's going to be some rain somewhere in every season, right? Like we're not turning off the convection. That's
right. And it's, if you look at the pattern of precipitation, it's widespread anomalies, but it is raining at higher elevations, which you'd expect. And the places that are the driest are the lowest elevations. So it's almost like the monsoon has sort of shrunk up to its preferential locations, and the activity has been slower in those locations, but it still hasn't been present. It's not like a wintertime drought that can occur in Arizona, where it just doesn't, it's like 100 days of no rain anywhere, including the tops of mountains and the bottoms of valleys.
These few areas, they're few and far between. And we do have enough data from rain loggers, from flood control district data, where we know that very few of the stations have actually seen average to above average for this time of year. So for example,
But I think it's making the distinction between there are areas where it will rain, it just won't rain as much as it normally does, and keeping pace with the expected climatology, which is different than our wintertime events. Yeah, I'm not trying to argue like the tops of mountains have diverged and are now above average. That's not even the case. It's like we have pockets of low elevation areas, like the Tucson. I don't know if Ben has this handy, but I think that the top of Mount Lemmon probably has had as much precip as some of the foothills locations. I don't actually know if that's true or not.
I looked up this morning from the Pima County Flood Control District, and I actually closed that page, so I'm doing this off memory, but it was something only like 3.5 inches at the top of Mount Lemmon.
Yeah, which is this like the equivalent, and they probably got that over a series of events where like you have to go down 5,000 feet, right, and you can get the same total. So it's like this is that the monsoon shakes up that normal elevation expectation because of the way the convection originates. But it's just interesting, I think, to think about. There are places in Arizona and especially New Mexico that you might talk to somebody and they go, yeah, it's not terrible. And I'm like, who are those people?
But if you increase your sample size, you'll get a like in a year like this year, or in a season like this year, you'll get a fairly quick understanding that those folks are fewer and far between.
Well, for sure. But this is our classic, like, monsoon adjusted by population density index, is that most people in Arizona have not observed much precipitation at all. And Phoenix, by far,
one event,
the epicenter of, misery right now. And, and like I was joking earlier, there's got to be there, at least on rain log, there are 30 or 40 really smug rain loggers in Tucson that got that event. Right.
Yeah, it's crazy. So the Pima County Flood Control District has a network of sensors across Tucson. Maricopa County has one across Phoenix as well, and there's other ones in the state as well. But in Tucson, I'm just looking at the data now. Ben plotted up the number of stations with above average, and it is like I'm going to do this eyeballing it here, like less than 10% of the 100 stations. So less than 10 stations are actually above average, whereas 90 or 90% of them are below average. So yes, high variability, but in a year like this where you just don't have a lot of moisture around, you're just going to get fewer and far between.
It's got a similar west-east gradient to it that it did last year, which is related to that, that you kind of think of that monsoon subtropical air mass as, it's not, you can think of it as being a continuous coherent air mass that moves north. And, it's kind of an amorphous blob that can get shunted off to the east. And what that will do is it will leave the western part of Arizona, the lower elevations, and the northern part of Arizona out of the action before it'll leave southeast Arizona out of the action. And that's exactly what you see as far as the precipitation anomalies are. There's lower expectation in those areas, but they go to zero really quickly. And then southeast Arizona, which should be much wetter than it is, has not kept pace, but has had some precipitation.
So Ben just slacked me. I might want to take back my bet, betting all my money or near all of my money, because the percentages are actually higher. So he says that there are 8 years out of 70 of this record in which the Tucson airport has received more than 5.5 inches in August and September. So if we receive 5.5 inches, we'd be above average. So, that's a little over 10%. So
yeah, well, and it's because, we were talking about this earlier, is that as we click over this date we're at in August here, the characteristics of the types of events that the monsoon season will see change. Like the risk of tropical activity or transition type events that drag up tropical activity increases. It's much less likely. The types of events you get in July are really different than you would get later in August. And, the forecasts for the 8 to 14 day are not good. but there's a little glimmer of hope in them, and there's some other signs of hope in the forecasts coming up.
Okay, before we get there, I want to ask one more question. Before you were talking about these sort of rogue storms, or not necessarily rogue storms, but they're days characterized by these isolated convective storms, and then there's days characterized by more widespread rain events, more widespread convection. We've had much more of the former than the latter this year.
Yeah.
Right? So what separates the two? Like, it's obviously the position of the ridge, but it's probably more than that.
Yeah, I think that, and this is a little research project that we've got going on in the background that we'll, I think, have more insight and can talk about it more in the future. But, some of the preliminary results they're confirmatory of what I think is kind of obvious, but the background, the type of event across Arizona and New Mexico that you see early on in the monsoon season, and it's also the most probable event of any day in the monsoon season, is isolated convection, where the whole region from wall to wall is not receiving a big widespread event, right? And so it's isolated convection. It's typically related to elevation. It's typically more probable to occur further south, where moisture is a little more accessible. So it kind of regresses to the climatology that you'd expect, which is a little bit wetter in southern Arizona and along the Mogollon Rim, right? So, and that's where I think moisture is marginal, and steering is probably marginal.
It's marginally enough to create storms? Or?
Yeah, I guess that's what I mean is that it's enough to spawn a thunderstorm, but it's not enough to organize it, or it's not enough for it to grow into something bigger or more organized. It's typically the big widespread wall-to-wall events that cover counties or the whole state sometimes. Is you've got really deep moisture, and you've got some kind of disturbance, some kind of easterly wave, or some really good shear profile in the wind flow pattern that will cause really organized thunderstorm development to propagate. And those kinds of events don't happen very often they don't happen. I don't have the numbers yet, but this is what we're hoping to get to, is like, how often do those kinds of precipitation events occur? And they're fairly infrequent. And the kinds of events that occur will be different in July and August and September, just through going through the evolution of the monsoon season.
So you and I were slacking a couple of days ago and just trying to come up with like the high level bullet points before we move on and talk about what if there are glimmers of hope. I think it would be handy just to sort of hit the high notes so far. And so came up with a list of a few bullet points. I'll get rid of all the expletives that you dropped in here amongst your dire predictions. But so correct me if I'm wrong on any of these, or add to them. So basically, the position of the monsoon high has been unfavorable, and most of Arizona has consequently been in upper level westerly winds all summer so far.
Yeah.
And that this has led to some competing effects, sometimes cooling off the upper levels and increasing CAPE, which would be on the good side, but at other times sort of eating away at the moisture availability. So being in an unfavorable position for incursions of moisture. So wherever you are in that wherever the ridge position is, it can either be favorable or unfavorable, and it's been bobbing around quite a bit. And then when the ridge has been overhead, that's sort of always bad, for suppresses CAPE, and it's not ideal for moisture. We've talked about that quite a bit. And then the only events so far, the few that have been widespread, the only ones that have been of consequences have been from deep southerly flow from these transition events, which maybe you can explain a little bit. And that's not supposed to happen in July. The final thing that we talked about is there hasn't been a widespread, really heavy event across Arizona, and New Mexico has fared better overall. So those are sort of the big picture points, but Mike, maybe explain the idea that the only events of consequences has been from deep southerly flow, but those are more like transition events.
This transition event climatology, I think it goes back to one of Bob Maddox's papers from the 90s. And we use this for severe weather classification just to look at the sort of synoptic scale. And so I think that's where that came from, is having a trough, mid-level trough off to the west, and having the subtropical ridge, mid-level subtropical ridge, slide off to the east. You know, it's like we've talked about this because we had deep southerly flow events in the like June 1st, which we actually had rain. We had better precipitation events in late May and early June that looked,
dew points were really good then. The June soon
looked more monsoonal than now. Yeah. And again, it's like that transition event isn't really even proper monsoon. You're not in the subtropical easterly flow, which is, you know, technically what we're trying to look for, is that as the mid-level ridge moves to the four corners, ideally south of that high center is flow out of the east. And then you're in the subtropics effectively at that point. And we haven't been in that flow for more than a day or two, I think, maybe 4 days, you know, the whole monsoon season. It's been really weak on that. But the days that did import moisture into the region were trough off to the west, high off to the east, and a good open door to the south, where there was convective activity in Mexico that was able to steer the moisture up into the state. And, you know, like you said, that's much more common as the subtropical ridge retreats to the south later in the summer. But we haven't had a strong advancement of the subtropical ridge to the north because it's been just beat and battered and knocked all over the place by a wavy jet stream, basically, in a pattern across the Pacific Ocean, which it's really interesting. If you kind of try to go into look at the different discussions on what's been going on to try to get some sense of why that's been the case, it's really not clear.
So thinking about maybe some glimmers of hope, is there any indication that those kinds of setups might be more frequent going forward? Or what led you to say that there's some glimmer of hope? Because on the one hand, the short-term forecasts look rather bleak. Next 7 days or so does not look really good for monsoon, and that takes us to mid-August. And then looking forward, what's on the horizon that might change the situation?
One of the things I noticed on one of the longer range forecast tools is you can look at the entire globe, and you can look at these metrics that give you a sense of big standing waves or waves that move in the atmosphere. And one of those we talk about is like the Madden-Julian oscillation. And you can see across the globe where in the tropics, where there's big organized areas of rising air and convection, and there are areas that are subsequently sinking. You know, so you've got these, Walker circulation where rising air is being compensated by sinking air. Well, there hasn't been a real strong organized MJO signal, Madden-Julian oscillation, but there's been hints of it, and there's been these other waves in the atmosphere, Rossby wave propagation in mid-latitudes, and then these little Kelvin waves that are much faster propagation of waves in the atmosphere that can occur over a matter of weeks, much shorter timescales than MJO. Anyways, all this kind of noisy stuff going in the atmosphere. One pattern has emerged over the last 30 days, which is kind of interesting, which is there's been a ton of rising air in the Indian Ocean or Western Pacific region, and there's been a ton of sinking air over Central America. And so that kind of signal it seems to be part of why there's been a really quiet East Pacific tropical storm situation for the last 4 weeks. And so we can't expect anything out of that. Well, the models are now hinting at a movement of that pattern and even some progression of what would be considered a Madden-Julian oscillation signal propagating to the east, which then puts that sinking air over the West Pacific and the rising air over the East Pacific. And if you look at some of the discussions from Climate Prediction Center, they have a really cool discussion, the global tropical hazards, I think it's what it's called. And I was looking at some of the discussions today, but one of the models does really point at the third week of the month, over 2 weeks from now, starts to open that up and make the East Pacific come to life. And that you're even starting to see that at the tail end of the modeling runs right now, is that starts to spin up hurricanes right off the coast of Mexico, and they start to move towards the mouth of the Gulf of California. That's all I got.
That's actually pretty good.
The Climate Prediction Center, the 8 to 14 day forecast and the week 3-4 forecast actually shows this, and it's so miserable because like all of Arizona except southern Arizona is like below average, but then there's this half of southern Arizona is like equal chances. So like the only glimmer of hope we have is like there's this hint that tropical storm activity will pick up in 3 weeks. But the thing is like that is no guarantee.
It's interesting though, when you look at the named storms that on average happen in the East Pacific, we're really behind schedule there. Like on average, it's been, 15 or so named storms in the East Pacific. And so far there's only been 4. So, we've got to move more closer toward the average, I would expect going forward, just in terms of statistics. I mean, it's hard to imagine that there won't be more activity because there's been relatively few activities so far. The prediction coming into this season was a slightly increased chances for above average in the East Pacific. So,
not for the East Pacific. The East Pacific was actually below average, right?
I don't believe so. They were saying this year that they were predicting 15 to 18 named storms, and on average it's 15.
Oh, okay.
They were predicting 8 to 10 hurricanes, and on average it's 7.5, and they were predicting 4 to 5 major hurricanes, and on average it's 3.2. So, of course, now I'm looking at there's conflicting reports here. NOAA predicted 11 to 18 named storms, so a much larger range.
Yep.
I was looking at the Servicio Meteorológico Nacional from Mexico.
Okay.
So Mexico was predicting above average, and NOAA was predicting below to above average. I mean, 11 to 18 is sort of, I guess average if you want to.
Yeah, they're official. Yeah, so they had a 75% combined chance of near or below normal season activity for the East Pacific.
Well, we're only at 4 right now. So
yeah, no, it totally makes sense because it's really cool to read these discussions because they kind of walk you through from beginning of July to present. And there was this really narrow window when a wave moved across the East Pacific where you did see development and then it quickly collapsed. And so on average, there's been suppressed convection across the East Pacific, which is expected to continue for the next week and a half. So that, that takes out that part of the recipe for the monsoon season, takes it off the table. But if it does open up, and again, it's an if, because, the skill in these models isn't great all the way out. And there's 2 different models that are kind of showing different things right now, is that you could get your 2-inch event at the airport out of a really nicely timed moisture surge late in August. And it's also when you'd expect to see widespread wet events occur climatologically.
Yeah, we need a few of those.
We do, for sure.
I do think it's going to take not just an event or even 2 events. It's going to take, a week to 10 day prolonged period of activity to sort of change people's ideas about this monsoon season. I mean, I think that the first half of this is going to overshadow even what happens in the second half in terms of perception. So,
well, and I think that there's consequential aspects of this monsoon season too, is we've struggled with this for years, but if you get all your precip the end of August and September and you hit average, ecologically, and, when we think about rangelands and livestock production systems, that's too late. Like the growing season is pretty short, and getting a lot of rain in July and then it not raining, but maybe temperatures are moderated is really different than getting no rain and then it all coming later in the season. The timing of the precipitation matters. And it's also, why, in our drought monitor discussions, this is as close as we get to flash drought here, is where regularly timed precipitation doesn't show up on time, the impacts can emerge pretty quickly after that. And I've heard reports that there's even fires in parts of Arizona in August, which is not normal at all.
Yeah, well, let's hang on the East Pack firing up and providing a week, 2 weeks, let's even say 3 weeks of like good opportunities for rainfall. How about that?
It's the only thing that's keeping me quasi cheery today.
All right, so really exciting news. Let's transition out of the dynamics of the monsoon to the
is this the gloating part of the podcast?
Monsoon fantasy. So thanks everybody for playing July's Monsoon Fantasy. We have a winner. We had 37 entries, and let me just review this quickly. People guessed what decile precipitation would fall in for July for each of 5 cities: Tucson, Phoenix, Flagstaff, Albuquerque, and El Paso. And if they got the correct decile, they got 10 points. If they were 1 decile off, either too high or too low, they got 5 points. And if they were 2 deciles off, they got 1 point. So if you were really good and the probability was 1 in 100,000 to do this, if you're really good, you would get all 5 right and get 50 points. Really low probability of doing that. So the highest score, Mike, was 21. So the winner, I won't mention, I'll just say his first name was Doug. So Doug got 21. And then there was 4 other people with 20. And Mike, I'm looking all the way down here. All the way down is Ben at 4 points. Wow. Pretty bad, Ben. Mike, you got 7 points. And I got actually 15. So not too bad.
You're wild. I mean, like, you have to swing for the fence. I mean, things have got to go so wrong from climatology to win in these situations.
Right. But Doug actually got 2. He got Albuquerque and El Paso right.
Yeah, Doug nailed it. That was awesome.
So that's pretty good.
And I know Doug too.
So I was just curious, and I was just thinking, like, well, did we do better than random? So I basically just wrote a little script and did 100,000 random guesses, and then took the average score of those random guesses. And it turns out the average score was 8.8. So Mike, you did worse than a random guess.
That sounds
and Ben, you did way worse. I showed some skill, and Doug showed some real skill.
That's awesome.
So congrats to Doug for that. We've posted, Ben sent out an email, and if he hasn't, I believe he did, announcing the winners. And all of your pseudonyms, we didn't provide last names, but you'll be able to recognize yourself in that email that Ben sent out. And the other thing is, we're doing this each month. And so for those who continually play, the winner after the 3 months, we're going to make a little gift for. We're going to buy a little gift for. And that's another exciting thing I wanted to mention is we finally got some swag. So we had this really cool logo, cartoonized cloud with headphones, and we made them into shirts and mugs. So the winner at the end of the 3 months will get either a mug or a shirt, whatever they want from us. So continue to play. On that note,
what if I win?
Yeah, you can win. Then Ben and I will buy it for you.
Oh, I like this.
You're not going to win, Mike.
I know.
I don't know. He's within one correct guess away.
Yeah, I do want to just say, bad score, yes, but I had 4 stations that I scored points on, where Mike only had 3 and Zach only had 2. So the value is actually scoring well on a few stations, because getting it kind of close on 4 was effectively useless. So that's new strategy.
Yeah, there's real strategy here. I think we haven't totally thought through. I mean, I was just going to play the climatology for every station forever. And I think after 100,000 times, I will win.
Yeah. Well, I was also going to say that if anybody wants to purchase a shirt or a mug with the cool logo on, they can do it at cost, which is what it costs to make it. But they can they can find that via our websites or in the emails that are sent out. So we'll have a little link that takes you to the company that you can purchase directly from them. I think it's like I bought a shirt. The premium T-shirt was something like $20 or $21, so not much, and really cool logos. All right, so we also had even more people play for August, Mike. So we had close to 50 people provide their guesses. Mike, do you have yours handy? You want to just?
I totally have erased it from my head. I don't remember. I really don't.
All right, I've got it. We did this. We should say we did this before the 2-week forecast, the 8 to 14-day forecast came out. So we did this at close to the end of July. So we didn't have any privy information. Okay, so what's interesting is for July, we sort of had the pattern where the average was lower in the Arizona stations or Arizona cities than they were in Albuquerque and El Paso. So they were lower on average than they were in New Mexico. And that held true for August as well. So by and large, people thought that rainfall was going to be a little bit less in Tucson, Phoenix, and Flagstaff in percent of average than in Albuquerque and El Paso. So I find that as an interesting just sort of pattern that's emerging. And that's happened both in July and August. So Mike, you were actually above average. You picked the 50 to 60% decile for Tucson, Phoenix, and Flagstaff. And then you went dry in New Mexico. So a flip of the pattern that we had seen in July. You did the 30 to 40% decile or 30 to 40 decile in Albuquerque and El Paso.
Ooh, this is good because I don't know why I did that, but that's what the forecast actually starts to look like coming up.
Yeah, well, I, on the other hand, I was really bullish in Tucson for the second month in a row, so 60 to 70%. I was 40 to 50% in Phoenix and 50 to 60% in Flagstaff. So overall thinking that Arizona was going to experience close to average, if not much above average in Tucson. And then for Albuquerque, I was 40 to 50, so a little bit below average, and El Paso 60 to 70%. So I was all over the map. And
you score points with that strategy? That drives me nuts.
Well, it was based on, a deep reading of the statistics, if you remember from our last discussion. Ben was also kind of had the sort of scattershot strategy as I did. 60 to 70 percentile in Tucson, the 30 to 40 decile in Phoenix, the 70 to 80 decile in Flagstaff, 50 to 60 decile in Albuquerque, and 40 to 50 in El Paso. So we'll have to see how that plays out. But we had about a little over 50 entries. I'm seeing some similar pseudonyms. So there's people that are in it for the long haul, and hopefully we'll play all 3 months. So yeah, this is a fun little thing, and hopefully I'll still have something to brag about, Mike, and Ben, you can fare a little bit better, and both you and Mike can do better than the random guesstimator.
Yeah, we'll see about that. So we'll see.
All right. So I wanted to end with a reading, believe it or not, because I was reading to my little infant Ellis last night, and this story hit me because I think it's very similar to what we're going through with this Monsoon fantasy game. So it's a Dr. Seuss book.
Silverstein?
No, it's a Dr. Seuss book. And by the way, there are so mind-numbingly bad children's books out there that I've just really been thankful for Dr. Seuss and some of the other really good ones out there. But so this is a story from, and I'm only going to read like a paragraph. So bear with me here. Some of you may know it who have little ones. So this is a little story about there's a bear and a rabbit, and they're arguing about who's better. And the bear's arguing that he's better than the rabbit because he's got this amazing sense of smell, and the rabbit's arguing that he's better than the bear because he's got better hearing. And as they're arguing back and forth, and they give their pitches as to why they're better than the other, this worm pops up, and he's like, well, I'm better than both of you because of my eyesight. So let me read this. It says, well, boys, the worm answered, that look that I took was a look that looked farther than you'll ever look. I looked across the ocean, way out to Japan, for I can see farther than anyone can. There's no one on earth who has eyesight that's finer. I looked past Japan, then I looked across China. I looked across Egypt, then I took a quick glance across 2 countries of Holland and France. Then I looked across England and also Brazil, but I didn't stop there. I looked much farther still. And I kept right on looking and looking until I'd looked around the world right back to this hill. And I saw on this hill, since my eyesight's so keen, the two biggest fools that I've ever seen. And those fools that I saw were none other than you, who seemed to have nothing else better to do than to sit here and argue who's better than who.
Wait
So
a
I was
minute.
like, this is us trying to predict the monsoon.
Oh, I thought it was the Madden-Julian oscillation you were trying to explain.
Oh, okay. Well, that could be too. But anyway, I was just getting a chuckle out of that as I was thinking about the monsoon and trying to predict the monsoon and seeing who's got better prediction than the other. And it's a fool's game, Mike.
This is fantastic. Fantastic, Zach. I think we need to have poetry readings at the end of all the podcasts from now on.
All right. Thanks everybody for tuning in, and we'll come back in a month or so and go over the winter of August, and hopefully by then we'll be in a little bit better mood and we won't have such a grumpy podcast, and Mike will bring us more good news about what happened in the East Pacific. So until then, have a great summer, or have a great rest of August, and stay safe.
Happy monsoon, everyone.
Oh, and I'm going to end it with a surprise. A surprise reading. Welcome to a rather grumpy edition of the South. I'll do that one again. Too much inflection there.